This conference will now be recorded.
Let's start today's session. So in the last session, we just discussed about Python database connectivity program. According to documentation, our next topic was decorator generators and so on, but I'm not going to discuss that. One more big topic is there that I'll complete first. That is multi-threading. After that, I'll go for remaining topics. But all topics I'll cover, but order is somewhat changing. So today topic is multi-threading in programming, multi-threading in Python programming. So before going to discuss about multi-threading, I need to talk about multitasking. Multitasking like this. Multitasking. What is multitasking? So simple that is multitasking means executing several tasks. Executing several tasks simultaneously. Simultaneously. Executing several tasks simultaneously is the concept of multitasking. Executing several tasks simultaneously is called multitasking. Called multitasking. Generally, in our daily life also we can do sometimes multitasking because to save the time only. But same here also in object-oriented programming Python. So multiple times, multiple tasks we can do in same interval period of time. That is called multitasking concept. We can say general for saving the time only. Multitasking means for saving the time. So executing several tasks simultaneously, that is called multitasking. Okay, executing several tasks simultaneously is called multitasking. There are two types of multitaskings are there. Two types of multitaskings. Two types of multitasking. One is uh, process-based multitasking. Process-based multitasking. This is also called as multiprocessing. Multiprocessing, we can say that. Next one is thread-based multitasking. Thread-based multitasking. This is multi-threading, we can call it as. This is called multi-threading. Process-based multitasking is there, that is multiprocessing. Thread-based multitasking is there, that is called multi-threading. But our topic is multi-threading only because we are going to focus on thread-based multitasking. So why not process-based multitasking? I will tell you. First, process-based multitasking or multiprocessing means what? So process-based multitasking means executing several tasks simultaneously. Executing several tasks simultaneously, where each task, where each task is a separate, independent process. Where each task is a separate, independent process is called process-based multitasking. Process-based multitasking. Process-based multitasking. Executing several tasks simultaneously. Task is a separate independent process is called process-based multitasking. We can say that. Okay, example. What is the example of process-based multitasking? Generally, I'm writing some code right now in Notepad editor. For this, our operating system is providing one process, and at the same time, I'm uh, what we can say speaking, and I'm going to give the lecture. I'm giving that is going to be recording in the GoToMeeting software in my computer. For GoToMeeting recording purpose, operating system is going to provide one process, two process, and at the same time, I'm trying to download a file from internet. For that purpose also, operating system is providing separate process. So totally three processes are running right now in my computer. Assume that. I'm writing code in Notepad. One process will be created. Next, I'm going to, that is one more process is going to be prepared. And at the same time, I'm downloading some file from internet. That is one more process. So totally three processes are going to be happen in my computer. So at the same time, we are doing all these tasks are executing simultaneously or not? Yes, writing code in Notepad, go to meeting, recording video, and what we can say, downloading file from internet. All these processes are executing simultaneously and independent of each other. There is no relation. Writing some code in Notepad is independent. Downloading file from internet is independent, and also recording the meeting in GoToMeeting software is independent. So this type of process is called process based multitasking. Yes, we are saving the time, only parallel task is going to be performed. But this type of multitasking is best suitable at operating system level. Okay, this type of multitasking is suitable at what level? OS level. OS level means operating system level only it's possible. So that is, I need to make programmatic level. No, programmatic level means we need to go for what actually thread-based multitasking we should go for. That is called multi-threading. So what is thread-based multitasking means executing several tasks simultaneously, where each task is a separate, independent part of the same program. Executing several tasks simultaneously, where each task is separate, independent part of the program. Same program. Okay. Independent part of the same program is called thread-based multitasking. Same program is called thread-based multitasking. Thread-based multitasking like this. And each independent part is called a thread only. And each independent independent part is called what actually? A thread. Each independent part is called a thread. We can say that. A thread, sir. It is a thread. Here each independent part is called a thread only. Okay, this type of multitasking is best suitable at programmatic level. Yes, this type of multitasking is best suitable for programmatic level only. That's what we can say. We are saying this is multi-threading programming is suitable for programmatic level. Programmatic level only we are using this thread-based multitasking, that is multi-threading. So operating system level is recommended multiprocessing, that is process-based multitasking, and programmatic level is suitable, that is thread-based multitasking, that is multi-threading, where each part of the same program is called one thread only. That means in one programming we can include multiple threads. Multiple threads we can include, not a problem. Okay. Yes. Now, whether it is a process based or thread based, no matter. The main advantage of multitasking is what? To improve performance of the system by reducing the response time only. Whether it is process based or thread based multitasking, no matter, the main advantage of multitasking is to improve performance of the system by reducing response time. Yes, response time means quickly we'll get response. It will reduce the responsive time. So the main important application areas of multi-threading are, so multi-threading application areas means uh, to implement multimedia graphics. In this also we use multi-threading programming, graphics, multimedia graphics, multimedia graphics to develop animation. Yes, to develop animations we can use, and to develop video games point of view we can use multi-threading, and to develop web server logics, web server logics, to develop web server logics. In this area, we can go for thread-based multitasking. To develop web server logics also we use this. This is exactly thread-based multitasking or multi-threading we can say that. So whenever a group of independent tasks are available, then it is highly recommended to execute simultaneously in that group So instead of executing one by one, so in this case, we can go for multi-threading programming. But in Python, to work with multi-threading programming, but there is a module called inbuilt module that is called threading module. Look at this, threading module is required. Import threading. Import is a keyword, threading is a module name. This module through only we can implement all the threading logics, all the thread classes, thread functionalities, multi-threading related stuff also present in this module only. In the program, if we use this import threading module means that indicates we are working with multi-threading programming. Every Python program by default contains one thread, which is nothing but main threads are. And one more important thing. Yes, so far whatever we discussed, lot of programs no, in our application, many programs topic wise I have discussed. In each and every program, uh, by default it's having one thread that is main thread. Every Python program, every Python program, every Python program by default, by default, by default contains one thread, which is nothing but main thread, which is nothing but main thread, which is nothing but main thread. Every Python program by default contains one thread, which is nothing but main thread. Okay, these are the main thread. So how do I know that whether it is main thread executing or not? Simple. Any program you can take, this normal program like test 43 is there, no last program. Let's give this test 43. Now here I'm writing something like this print hello. So I'll show you whether it is multi-threading programming or not, a single threading programming or not. As I said that it just come and I want to debug this program. Test 43, right click and debug for test 43. Once debugger window started, you just observe here and debugger window after you can see this main thread is looking or not. This is the main thread. That indicates that by default every Python program is having one thread that is called main thread, sir. So every time it is executing this main thread on. So if you want, you can get main thread name also. I will show you how to get main thread name clearly. Okay, just a moment. Just I want to show you whether this is executing under one thread, which is main thread or not. I'm showing. You can see this. There is a main thread clearly available. So that means every program, Python program, by default, it's having internally one thread, which is nothing but main thread. This main thread name, we can get it, and we can change the name of the main thread also, not a problem. So how to get and set main thread name, if you want to see this, then there are some methods are there. Let me use that. So I'm creating separate one by one program which is related to multi-threading program. I'm creating now. Let's create now new Python file and I'm taking thread one. Thread one is my program name. In this program, I want to show you how to print the name of current executing thread and how to change the name of current executing thread. So as I said that every program is having one thread that is main thread. Okay. So how to print the current execution of thread and how to change the current execution thread name only. Let's see this program quickly. But how to get means compulsory we have to include what? One module, threading module. So on the top, import threading I'm using, and to get the current execution of thread, so threading is a module name, dot current thread is a method name, dot get name is the name of the method. Look at this. The moment when I try to use this get name is showing like strikeout, something strikeout, because this is the older version method. In my documentation also, which I said advanced Python documentation PDF, in that PDF also there is a get name is there, that was old version method actually. So note this, whenever in your program any old version method if you are using, that method will be strikeout, but it will work, but it will suggest you better to change the new version methods what is there. Okay, even some warnings also you will get, so notification will come now. Let's run this thread1.py. Now you can see once we have thread1.py execution, now you can see we got the output clearly. We are looking current execution thread is threading is a module name dot current thread is the method name of get name is a method name. We are having what's our main thread only name of the method name of the main thread. Yes, fine. But along with this, what we got warnings we got or not? What warning? Deprecation warning. So they are saying warning through get name is deprecated, means it's not useful right now. Currently, which version of Python you are using, it's not recommend. So get name is deprecated. Get the name attribute instead means instead of this get name, we can say that name attribute they are asking to use. Okay, instead of get name. So to avoid this, what we can say warnings. So better to go for what actually instead of get name method, it is old version method. Instead of that, we use what actually name attribute only. This is not a method, it's an attribute. So if I change this, now you can see we got this main thread name only, but we were avoiding that what warnings. So warnings are completely avoid. So that is main thread only, it's available now. This is the name of the thread what we have, what we are getting now, main thread only. Print threading dot current underscore thread dot name only here. Okay, so main thread clearly. Okay, threading dot current underscore thread dot name. Sir, how do avoid this warnings also? Sometimes suppose still programmer wants to use this get name only, that is older version method, but he is getting output, but deprecation warning also there. How to make these warnings are silence? So to make warnings or silence, that is one more technique is there, that is import warnings is there, warnings library. And here I'm using warnings dot filter warnings, and I'm taking ignore message. After that, category equals to what warnings you want to silence, means category equals to deprecation warnings are there. Deprecation warning. So if I do like this, what will happen? These warnings are completely silenced. Only you will get what main thread is the output actually. Though here I'm using get name method, so it's a older version method. If you use older version method, obviously warnings will come. If you want to silence the warning, if you want to make silence warning, this import warnings is a library. Warnings dot filter warnings is a method, and ignore category means what type of category of messages you want to warning, means deprecation warnings I want to silence. And sometimes you will get different warnings like future warnings also. Okay, so many warnings are there. That warning type of messages you can make silent. To do this, you can do it once. Otherwise, you can better to use what actually latest version. According to that, I'm using name. So instead of get name, they are suggesting me name only. So that's what we are getting name. This is what currently your program is executing. In which thread do you want to know that? You can come to know that. But by default, every Python program executing under one thread, what is that name of the thread? Main thread only, sir. That's what we are getting. Name is main thread only. If can we change the name of the thread? Like instead of main thread, I can go for any other name. Yes. How we can change threading dot the module name dot current thread is a method name. Then name equals to what we have to use. Again, if we, actually in older version we have a method called set name. Set name in the sense, for example, I'm taking the sample thread. Sample thread is the name of the setting. So I'm changing the name of the thread from main thread to sample thread. We are changing this sample thread. Sample thread name changing purpose, we use an older method that is called set name. Again, deprecation warnings are there. To avoid warnings, then what we can do simply name equals to sample thread we are using. This is fine, sir. Now you can see sample thread name is changing or not. How do you know? Again, we can print that threading dot current thread dot name. Then we are getting what actually sample thread. Initially, by default, a program is having one thread. that is main thread. If you want to set the name of the thread, we can use this name property, sample thread. Whether it is changed or not, we have to get threading dot current thread dot name. So now sample thread we are getting here, sample thread. Got it? Yes. So every time, is that required to import like threading dot? No. So you can use this import threading is a main module name, as th means alias name. So you know that once we use the alias name of the module, so every time we have to use alias name only. So you can just ignore the main name. So import threading as th, and th only I'm using because it is alias name, it will work. Or else, even if you don't want to use any alias name, and even if you don't want to use any name like threading name, so simply you can ignore it. So directly you can import like this. How? From threading import star, like this. From threading module import star. Star means indicate all, everything will come. So this is better. No need to use any module name or alias name. Directly we can use what actually names like current thread dot name, current thread dot name equal to like. This is the basic programming which is required to work with multi-threading. So current thread is every time main thread only, which is always. By default, every Python program contains one thread, which is nothing but main thread. So main thread is required here, main thread. Okay, fine. Next, what we need to do. So I want to show you clearly difference between single threading program and multi-threading program, because up to now whatever we discuss, all the files, all the programs that are single threading program, because every program is having its own thread. By default, that is main thread, means single threading program, that is. And I want to show you the difference between single threading program and multi-threading program, means how time is going to be saved. Single threading program means simple, sir. When we have a multiple functions in one program, when I start executing that program, the way of calling the functions orderly, it will work. First function, when we call that function, will execute start. It will start the execution. After completion of execution, first function, then immediately next function execution begins. Like that, that function execution start completed after third function execution begins. Like that, it's keep on like that. Okay, so that is one by one. So not combinedly all functions at a time, not. That is single threading program. Obviously, when we have multiple functions in our program, one by one function, if you start executing, so it will take time, no? Execution purpose, it will take time. So when we have a multiple methods parallelly, when we start execution, so obviously we will save a lot of time. So that is what actually we are saying. Let's see the difference between single threading program and multi-threading program. Okay, so just for our understanding point of view, later we'll see how many possible ways to create threadings and how to work with threading concepts we'll discuss. First, you have to understand what is the main difference between single threading program and multi-threading program. So thread 2 is my program. Right now I'm not importing any threading module. That means we are not working with multi-threading, normal programming it is. Normal programming in the sense I am creating two functions here, simply square function, which is accepting numbers at runtime. So the moment when we go for square function for n in numbers, then every time I want to I want to make waiting period, import time I'm taking, time dot sleep, time dot sleep off. So I'm taking 1 second, time dot sleep 1 second I'm waiting. After that, I have to use print function. Square is then n into n only. This is square. The square functions are simple normal Python function. Df square of numbers for n in numbers. Time dot sleep of 1 second, and square is n into n. Next, what I'm taking, df cube function also I'm taking cube. Cube is the function numbers for n in numbers, and time dot sleep of actually 1 second, and then print cube is and n into n like this. Now simply I'm calling this square function and cube function. To call these functions, first what we have to require, inputs required. Number of inputs I'm taking, multiple values I'm passing to the square and cube function. That's what I'm using loop through iteration for added number means one by one number will collect from these numbers and print that number, cube and cube. So let's see this numbers equals to, I'm passing 2, 3, 4, 5, 6, 7. Okay, then square function I'm calling by passing these numbers. Cube also I'm calling by passing these numbers. Now observe here, when I start program execution here, okay, when I start program execution, so how it will be uh, uh, executing, you just observe by looking the output only will come to know that whether it is single threading program or multi-threading program. Single threading program will obviously, now you can see one by one execution start. Square is 4, square is 9, square is 16, square is 25, square is 36, like this. Next, after completion of square function, what function has started? Cube function has started. Means, so this is parallel execution or one by one execution. This is obviously one by one execution. We got clear output here. First, a square function is executing clearly, and then after cube function is executing clearly. So that means what? So square and cube both functions are executing. One by one execution is over. Square, square, square. After that completion of square, cube, cube started. So by looking this execution process only will come to know whether it is single threading program or multi-threading program. Obviously it is what? A single threading program only. Now you can say single threading program. Okay. Yes, but my requirement is I want to calculate the time, because as I said that multi-threading program, single threading program, main difference is what? Responsive time. Means how much time it will take. One by one task if you do, it takes obviously more time. All task if you do, then parallelly multiple tasks at a time simultaneously if you do, means it will take less time. But our main motto or intention of multi-threading program is what? Multitasking only main goal, means parallelly execution required, so that we will reduce the time clearly. But here right now I'm working with two functions in my program. Right now two functions are individually working, but how much time it will take, I want to know that. How much time it will take. Time purpose I'm taking t is a time object, time is a module name, that time is a method name. Okay, and I'm trying to calculate the time. So done in how many seconds. I want to say that time is a module name dot type is a function name of hyphen t is my time object here. Time object. Using this line, we can calculate the time. This is hyphen t. So t is time object. So automatically after execution start, this is one by one function execution, not parallel execution. Now how much time it is taking, you can observe here. Done in 12 seconds. So time, this process after executing square function separately and cube function separately, how much time is taking? Execution time is 12 seconds. Execution time is taking nowadays. This is single threading program, because one by one function we are executing. Let's convert this program into multi-threading program. How do we convert this program into multi-threading program? In the sense, simple. On the top we have to import what? Threading module, obviously, or from threading import star also you can take. Let's take import threading module for clarity. Now here I'm not calling these two functions directly. Instead of calling these two functions directly without threading, I need to create a threading here. Threading means threading objects you have to create. T1 is an object of thread. Threading is a module name. Thread is a class name. It's a built-in class. How to create object for class? Object name equals to class name. Class name is a thread, but this class is present in which module? Threading module. So module name dot class name. So using this T1 thread object, which function do you want to execute? That function we can provide in the target attribute. Target equal to, my target is square function. Okay. And the square function is having what? Actually parameters or not? The square function is having what? Parameters. Parameters what? Numbers only. Now you can see Square function is having parameters, that is numbers. T1 equals to threading dot thread, target equal to square. Now you can see here args equals to, we have a parameter, so that's what here numbers comma like this. T1 is a threading object equals to threading dot thread class. Threading is a module name dot thread class. Which function you want to target using this 3 1 object? Square function. The square function arguments are there, so that's what args equals to numbers. We are passing this input parameters. And next T2 thread I'm taking for second method targeting. Threading is a module name, thread is a class name, target equals to, now this time I'm giving target for this cube. Args equals to what actually numbers. So that is even T2. Two thread objects are there. But look at this, you are ready with the thread objects T1 and T2. But when threading will start to call the square and cube function, so you must and should start the thread. To start the thread in Python, what we need to use T1 dot start method compulsory, T2 dot start method also compulsory. Okay. So after starting the threads, if you want to make one thread execution after another thread waiting purpose, then we use join method. I'll talk about join method also in upcoming examples. Clearly you will get clarity. Join method is required here, t1 dot join, t2 dot join. Just try to understand the difference between normal single threading program and multi-threading program. So we have created two threads t1 and t2 by taking help of threading class threading module name dot thread class, and t1 dot start, t2 dot start also have created, t1 dot join, t2 join, and time period also I'm taking. Previously when I was executed a single threading program, time was actually what, 12 seconds only. Okay, 12 seconds. And this time you can see this is multi-threading program, no? So how much time you see this by looking the output process output execution process, you will get clarity whether it is how it will execute. Now you can see the moment when I start execution, so parallel execution is running or not, square cube at the time same time only it is executing. Now time also you can see this how much time taking here, 6 seconds. So previously when I was discuss about single threading program, that was happening 12 seconds. Meaning is what? Half of the time we have reduced or not? Yes, half of the time we have reduced. Half of the time we have reduced. So 6 seconds we have. So let's run this now. This time you can see this. Square, cube, parallel execution is happening now this time. Parallel execution is happening. Done in few seconds like this. Okay, done in few seconds. 6 seconds only. So total time is how much reducing, sir? Half of the time we have reduced because it is multi-threading program. So parallel execution it is executing several tasks simultaneously where each task is a separate independent process of the same program, where each task is an independent part of the same program. Independent part means square function is one separate independent part, cube function is separate one independent part. So for that both are separate independent part. So this is multiple task we are executing parallelly. So that's what we are increasing, we are reducing responsive time. Responsive time is quickly it is coming without delay, because both tasks parallelly we are executing, no need to wait. But sometimes you can see this when we are working with multi-threading programs or parallel execution, output we are not getting as we expected, means order irregular output will come. It's a common in working with multi-threading programs, irregular output only will get set now because multiple threads are running parallelly. So that's what irregular output will come. Don't look at the output, we will make this output as a regular by using some techniques, synchronization techniques or the thread synchronization techniques. Okay, that techniques through we can adjust this output clearly. But only we should focus single threading program how much time is taking, half of the time it is reducing for multi-threading programs. This is conversion multi-threading program here. How do you recognize whether this program is executing parallelly or not? Threading module is there, no? Yes, threading module. So if you want, we can change this from threading import star also. No need to use. So thread is a built-in class. For this class, I'm creating object T1 and T2. These two objects through only we are targeting the respective functions. So both T1 and T2 are started this executions for executing square and cube function by taking numbers. Parallel execution is running. So this is the main target of our multi-thread, okay, multi-threading program. So that's all about today. Today I'm closing the session somewhat early because I should reach today my institute quickly at sharp 8:30. I should be there. So today only. Tomorrow I'll take for all announcement here. Uh, Still, apart from multi-threading concept, we have these concepts are there in Python: decorators, generators, packages, logging, assertion, and what we can say pandas, matplot, lib. These are the topics are available. Once after completion of multi-operators, generators, packages, logging, assertion, pandas, and matplotlib. These topics are there. These topics purpose still 6 to 7 classes it's required might be next week middle. I'm going to start Django and I'll announce the batch and I'll inform you all once again. Django that might be starts with 6:30. It will start 6:30 a.m. instead of 7 a.m. 6:30 only because right now currently one batch is going 6 to 7 a.m. So in that batch also some Django students are there. For all students and 7 a.m. students combinedly Django I'm going to start at 6:30 a.m. 6:30 to 7:30 it will be there and I start Django 7:30 a.m. daily this time only. It's going to happen when I start Django. Middle of or Friday or Thursday or Friday, we'll announce the batch after completion of these topics to you, and I will make ready for 6 a.m. students also. They are also some of them have enrolled for full stack. Then obviously full stack student they should attend for Django sessions. So for that 6:30 a.m. to 7:30 a.m. you should attend for Django. When it comes to Django, I will start. I'll inform you once again. Still, we are in the process of to complete your advanced Python topics. But except multi-threading, only big topic right now. But these are all small topics only. We'll see that in future. Okay. But next week for sure, I'll start Django. After Django, rest after that Flask. All frameworks will be covered from now onwards. For that, compulsory Python is a mandatory. So that's what I complete Python first. So you just be prepared for this 6:30 a.m. to 7:30 a.m. when it comes to Django only.